Hello, I'm Myungju from Samsung, and I'm going to present you about the NNStreamer, which is to promote efficient and agile development of on-device AI systems. So first of all, what is on-device AI? Conventional AI systems in embedded systems have been using cloud systems to process neural networks instead of doing it directly in on mobile devices or television or other embedded systems. With on-device AI, we have been starting to use such inferences in the embedded systems. First of all, in order to keep the privacy and promote data protection, we started thinking about on-device AI because we do not need to send any data to the cloud or servers, and we can keep every data inside the user's devices. And it has low latency, especially if the data to be processed or inferences are huge. For example, if we are going to inference things with the live video camera's feed, then it may take too much time or too much resources to send the data to the server and get the result from the servers. And this is sometimes neglected factor, the operating cost. For example, if we have more than million devices or like 100 million devices deployed to the deployed for the consumers, then it may take too much cost to process such data in clouds. So if we promote using on-device AI, then we can save a lot of cost as well. In general, such on-device systems has higher requirements for their performance because they are assumed to process live data with large bandwidth, such as video camera. It requires lower latency, although it has less capable hardware in devices. And sometimes we have more complex systems than servers because we have multiple sensors and different various neural networks that are required to process data in real time. Another problem is that in on-device systems, unlike server systems, we have a lot of different products and a lot of different requirements and hardware specifications. In such environment, our purpose of the framework or NNStreamer is to process any input or output data structures of neural networks, including audio, video, text, radar, user data structures, or any arbitrary binaries coming from the sensors. We wanted to process many different neural network frameworks and hardware accelerators, and we did not want to depend on specific application types, whether to process object detection or classification or speech recognition. These requirements are described in the paper. Requirement number 1 was to fetch and process multiple input streams. This is kind of example use case of such multiple input streams. We wanted to make the components highly portable and reusable because we have very different types of devices produced, and we wanted to share the same software components and or neural networks. We wanted to make the components very portable and reusable. The system should be highly modifiable, and it should be easier to utilize parallelism and synchronization mechanisms. We wanted the wide range of off-the-shelf video filters or any pre or post processors. In many different systems, we decode or pre-process many different types of video formats or audio formats, and many developers try to re-implement or implement their own based on different libraries, but we didn't want our developers to re-implement such common media filters. And then the requirement number 5 was to support general binary streams as our stream types, and we wanted to support cyclic pipelines. And we wanted to support different neural network frameworks. We wanted to support such various frameworks inside a single instance of application, because in many research prototypes, there are many different organizations involved, and they may use different frameworks in their own individual organization. Even if this is a product, not a research prototype, we may use different hardware accelerators, and we wanted to use all of such accelerators inside a single instance of application. So how did we solve or mitigate such issues or requirements? Our first principle was to perfect the field, not not trying to reinvent the wheel itself. So we have found that GStreamer is going to be the base frameworks, which is going to be the already invented wheel, and we wanted to make it perfect for our own application. GStreamer is already stable and standard multimedia stream pipeline framework in Linux or other operating systems. Fortunately, most of the requirements in the previous slides were already solved by GStreamer. We can just reuse GStreamer for our own problem. The only remaining problem is that this GStreamer is not compatible with general neural networks. And this GStreamer is well maintained, better proven. We have been using GStreamer for 20 years already. And it's modular and it's open source software, so we can freely modify it for our own applications. How do we perfect it? Because GStreamer is for multimedia applications, not neural network applications, we first needed to make GStreamer understand neural networks and make this GStreamer be on basis of AI services and applications. This is an example application in our own paper, the example number 2. This is a activity recognition sensor, which detects the activity in a room. It detects if a person fell down, it will send an alarm to a central server. And this is a product that is installed in a few hospitals or elderly cares. In the original application, they have written a pipeline code over 1,000 lines of code, and it had higher cost because they spent many weeks with 2 or 3 developers, and they had higher CPU usage, higher memory usage, and it had lower throughput, and this was not very portable. And with this NNStreamer, we could rewrite the application within just 20 lines of code. It had lower cost because it took about 4 hours to implement, and it had lower CPU usage, memory usage, and it had higher throughput, and it was highly portable. And right now, we are using NNStreamer in various products in Samsung. Galaxy Watch 3, the wearable devices, has been using NNStreamer since last year for smart reply or other intelligence applications. And the mobile phones will be using NNStreamer with the next updates for its Bixby services. Next generation of TVs and home appliances is going to use NNStreamer for its on-device AI capabilities. It supports Tizen since 2019. It is compatible with Tizen Studio and Tizen APIs. And Android is also supported. We support Android Studio with JCenter, and it supports other Linux distros and macOS. The neural network frameworks supported with NNStreamer are here. We support various types of neural network frameworks and hardware accelerators. And we also support other frameworks that can be connected to NNStreamer, including RobotOS, Linux IIO, or MediaPipe, Protobuf, all the other different types of frameworks. What you can do with NNStreamer is to implement your own on-device or in-server AI systems with less efforts, with more features for low-cost devices to the higher cost devices. This is an open source software. It's eligible, so you can use freely for your own commercial applications or your own research projects without worrying about opening up your own application codes. Anyone can participate in our framework, so any discussions or questions inside our mailing list or GitHub issues is welcomed. And code contribution is also welcome, so you can send your own code to modify or update NNStreamer. Most of the contributors are working in Samsung Research. We are working in Seoul, and actually we are working in GitHub. Every discussion or project plans or implementation activities are in these GitHub open pages. So for more information, you may try the longer video, or you can visit our GitHub page or install and use via our binary deployments. Thank you.
Hi, everybody. Welcome again to the Deep Neural Networks Supporting Software Engineering Tasks #2 session. My name is Ira Vegas. I will be the session chair, and we have today with us Ham. Sorry for, if I didn't say the name properly.
That's okay.
He's going to answer all questions you may have about this great work. So we are waiting for your questions in case you may have. For the moment, there are no questions, but remember that we are waiting for them. It will be great if you have some questions to ask. Okay, so in the meanwhile, while some questions arrive, I think I have a question, okay?
Right.
Maybe there's something that you mentioned in the paper, but I didn't get it during the presentation. So you mentioned several benefits of your proposal compared to the previous approach, but I missed the details of, or quantitative details of how much is it really improving the previous approach. So I don't know if you can give us further explanation of what are the benefits of the new approach versus the old one.
Right. If we compare our approach against the conventional approaches, there is not pipeline or pipeline filter architecture, then we improve the modifiability and the reliability of the given applications. And if we compare ours against other competing approaches, including media pipe or deepstream of NVIDIA, then our approach is for just general hardware and other frameworks. So we do not restrict the usage to NVIDIA's hardware or cloud systems or server systems. So even if you are working on iOS devices, Android devices, whatever device you have, theoretically you can use our approach for your own device. And most of all, our approach is for general neural networks, not just for any special purpose neural networks. So you can apply ours to any other types of applications. So if you are using NVIDIA's, then you are restricted to object detection or segmentation or any vision applications. But with our approaches, actually, the types of application just doesn't matter. So ours is more general, and it's for arbitrary types of applications and devices.
Are waiting still for questions, but I have one more for you. I have seen that I think it was in the watch. It was already working, right?
Yeah.
Your new approach. But there are some devices that you plan to make it work on, like the TV, as far as I remember, and also refrigerators and things like that. So have you already started to do some kind of preliminary, even though it is still not available for the general public? Have you already started to make some tests on these devices? And if so, what are the results that you are obtaining?
It is not just in the test phase. It is already deployed to business divisions, and we have released it to business divisions. So I guess within months, we will have new televisions and refrigerators using NNStreamer. And you're muted.
To mute myself so that there's no noise. So Miroslav Staron has a question for you. He congratulates you for your very interesting work. And then the question is, do you have any thought how to use that in self-driving cars scenario?
Actually, the first purpose of NNStreamer was self-driving cars. So this was the original purpose of this project. And yeah, because there are live sensors like cameras or lidars, radars in cars, and we can use the data from those sensors as stream data, and we can apply different types of neural networks in cars. So yeah, I think that's just straightforward because this was the actual original purpose for this project.
Do you think, going back a little bit to the self-driving car scenarios and in general, I mean, trying to extrapolate the use of your approach to other devices that you have not yet considered, do you think it will be needed to change something in the current architecture or how the solution has been developed in order to cover more devices?
We are trying to expand the usage of NNStreamer to home IoT scenarios or edge AI scenarios. So we are trying to add more features for connecting pipelines. So we want to make multiple pipelines in multiple devices, and then we want to connect them with stream pipelines. So we are constantly writing those features, including like MQTT pops up stream connections and some query streams. So yeah, our future release of next year will have full of those kind of edge AI scenarios.
Answer. Are there more questions? Because it seems that probably your work was so clear and so neat that people don't have any kind of doubts or questions. So, okay, so no more questions are coming in, and I think I don't have further questions for you. So still we have like 3.5 minutes to finish, but I think that at this point, we can all take a maybe longer break. Oh no, there's something
my
that...
message. Yeah.
Okay, so this is
it's open source, so you can just come in and contribute.
Okay, so in 3 minutes, then I think you can join the private discussion room with the author in case you want to continue with the conversation. And I think we can all take a break. Thank you very much for being here with us. Bye. See you in the next paper. To the rest of the people, bye.